Alright guys, so now let's talk about the section 4.1. This section is a mix between the 4.1 and 4.2, and then I will get back to you with the section 4.2 individually. So this section, rational function and graph, what you have to do is very simple. Try to understand that you are going to use your calculator to represent the graph of each function, and you can understand also that when you have to represent the function f of x equal 1 over x, the calculator is going to give you this graph. Obviously, if you want to graph this function by hand, you could by using your table. When x equal 2, what is the value of f of 2, what is the value of y, etc. for all the different value of y, but you will also realize that your x cannot be equal to 0. So when you have a rational function, and your rational function is defined as the quotient of two polynomials, well, the polynomial on the denominator cannot be equal to 0. In the example below, the example f of x equal 1 over x, the polynomial is x, so very, very simple polynomial, and x cannot be equal to 0. I would encourage you to take your calculator and try to graph all the different problem example you have, like the example number 2. Try to do also the example number 1. Once that is done, let's try to focus on the graphs and the particularity of each graph. Okay? So a rational function is anything defined as f of x equal the division of two polynomials, p of x divided by q of x. Please do not be confused between p and q as the way to define the zero of a polynomial with a very higher degree, rather than with the p of x divided by q of x, where p is going to be this time p of x, a polynomial. Okay? Now, we want to find the vertical asymptote, and to find the vertical asymptote, it is pretty easy. It is when your denominator will be different than 0. So, here, in this case, my denominator different than 0, x squared minus x plus 20, if it was equal to 0, would have given me, by using the quadratic formula, or by factoring directly, two value of x equal 5 and x equal minus 4, and x equal 5 and x equal minus 4 will be the vertical asymptote. By the way, we do now understand why it is vertical, because we know that when x is a constant, no matter what value of y you are going to have, x will be always equal to 5 or negative 4, and so we are supposed to have a vertical asymptote. Now, we could have also an horizontal or an oblique asymptote, and maybe sometime both in the same time. So, the oblique and asymptote as well as the horizontal asymptote can be determined by looking at the degree of the numerator and the degree of your denominator. They fall in 4 cases. In the case number 1, if your numerator and the denominator have the same degree, so when you have the same degree, you have an horizontal asymptote, okay? But no oblique, all right? So if you look at the example number 2, you see that the degree of the top is 1 and the degree of your bottom is 1. You have the same degree, and so to find the horizontal asymptote will be defined as the fraction of the two leader terms, the top divided by the bottom, and so the coefficient in front, the leader term, for the numerator is 3, and the coefficient in front of the leader term for the denominator is 4, so your horizontal asymptote will be equal to 3 over 4. Now, the second case, the denominator has a higher degree than the numerator. If you look at the example number 3, you will see that the denominator has a leading term, degree 2, when the numerator has a leading term degree 1. So your denominator has a higher degree than your numerator. And in that case, we have an horizontal asymptote, but no oblique asymptote. And the horizontal asymptote is y equals 0. All right? You need to know that perfectly well. Now, the case number 3. Let's say that now the numerator is exactly 1 degree higher than your denominator. Look at the example number 4. We got the leading term of your top, of your numerator, is degree 2, and it's exactly 1 degree higher than the degree of the leading term of your denominator, which is 1. So, because of that, we will have an oblique asymptote, but no horizontal asymptote. And to find the horizontal asymptote, we divide the top by the bottom. We divide the numerator by the denominator. And for that, we can use the synthetic division. So if I want to do the example 4 with you, what I'm going to do is I'm going to take the negative 1, and then I'm going to have 2, negative 1, and 6. I'm going to bring down the 2. 1 by minus 2 equal negative 2. I'm subtracting, so I'm going to have 1 plus 2, I'm going to have 1. Alright, so on the bottom now I have 1. Minus 1 by 1 gives me negative 1. I'm subtracting, so 6 plus 1, 9, because minus by minus give me a plus. 6 plus 1 equals 7. And so that means that my f of x is going to be equal to a 2x plus 1 plus 7, which is the rest, divided by x minus 1. Okay? And so 2x plus 1 is going to be your oblique asymptote. Alright, 2x plus 1 is going to be your oblique asymptote. Now, if I take a look at the case number 4, if the numerator is 2 or more degree higher than your denominator, if you look at the example number 5, you will see that your numerator has a degree equal to 3, and it's a degree, the numerator is 2 degree higher than your denominator. Your denominator is 1. Let me erase the little mark that I did. I'm going to just do a dot. 3, and right there we have a 1. So the top is 2 degree higher than your denominator. And for that, if we have that, we're having a no horizontal asymptote and no oblique asymptote. Alright? No horizontal asymptote, no oblique asymptote. So, let's try to graph the example. Let's take a look at the example number 6. When you look at the example number 6, you got f of x plus 2 divided by x minus 5. If you're looking for the vertical asymptote, you are going to try to look at your denominator as to be different than 0. And if it's equal to 0, it's going to give you x equal 5. And that is going to be your vertical asymptote. Okay? Now, you will also realize that the degree of your top is 1, and the degree of your denominator is 1 also. That is the case number 1, and that means we're having an horizontal asymptote, and the horizontal asymptote is supposed to be the fraction of the degree of your top divided by the degree of your bottom. The degree of the top is 1, divided by the degree of your bottom is 1 also, so the horizontal asymptote is going to be y equal 1. Alright guys, so now let's take a look at the example number 7. And if you take a look at the example number 7, you can see that the leading term of your top is 1, when the leading term of my bottom is 2. And that is the case number 2. And the case number 2 is telling me that when my denominator is 1 degree higher than my top, I'm going to have an horizontal asymptote, and my horizontal asymptote is going to be y equals 0. So I have, when I graph my denominator, I will have an horizontal asymptote at y equals 0. Now, if I want to look at the vertical asymptote, it doesn't matter. That I just need to do is take a look at my denominator, try to solve my denominator as if it was equal to 0. As you can see, I have a quadratic equation, and to solve a quadratic equation, you can use your quadratic formula, or try to factor directly your quadratic equation. And at the end of the day, in this example, you see that you have a vertical asymptote, x equal -2 and x equal -3, as well as an horizontal asymptote, y equals 0. All right? So, let's take a look at the example number 8 together. What do we have in the example number 8? On the example number 8, we have a numerator with a leading term 2. So we have a top, leading term 2, and this leading term 2, when the bottom has a leading term 1. And that is exactly the case number 3. Okay, that is exactly case number 3. Which means we have an oblique asymptote and no horizontal asymptote. And to find the answer to that question, we are just going to try to use the synthetic division and divide 2x squared plus x plus 1 by x minus 1. Using the synthetic division, I take minus 1, and I'm going to have a decreasing exponent in x squared, x, we're good. So I'm taking the coefficient 2, 1, and 7. I bring down the 2. Minus 1 by 2 equals -2. I'm supposed to subtract. So 1 plus 2 equals 3. Minus 1 by 3 equals -3. And I'm subtracting. 7 plus 3 equals 10. And up to have the function f of x equal 2x squared plus x plus 7 divided by x minus 1 equals 2x plus 3 plus 10 divided by x minus 1. And my oblique asymptote is going to be 2x plus 3. This is going to be the oblique asymptote. Alright guys, so now I'll let you do the other problem in class, and we'll talk about that by the next session. Thank you very much, guys.